All right, greetings, my darlings. We are now on Module 10, Polynomials and Factoring. So before we dive into notes, we need to understand some vocabulary terms. So in your first page of your notes, we're going to start with Lesson 0, Vocabulary. Monomial. As you can see, a monomial is a number, a variable, or a product of a number and one or more variables. So for example, we could be looking at the variable x, or 3 times x squared. That's a monomial. Or we could even be looking at something as complex as 7ab x cubed. Even though there are 3 terms here, 4, 7ab and x cubed, that's still considered a monomial. They are multiplied together. Binomials is the sum or difference of 2 monomials. So when we say the sum, we could do something as simple as 5x plus a negative 2y. Well, folks, as you already know, positive times a negative is a negative. So we could be looking at something like 5x minus 2y as a binomial. Another binomial is something as simple as 2x plus 8. Notice how it is basically 2 monomials separated by an addition or subtraction sign. Again, you already know this, you guys. Trinomial, that's right. Mono means 1, bi means 2, tri means 3. So this is when you take 3 monomials and you're adding or subtracting them. So an example of that would be 5x squared minus x minus 4. Another example of that would be a negative 3x squared plus x plus 2. You can either add or subtract. Your monomials are separated by an addition or subtraction sign, and sometimes starts with a negative number. Okay, so polynomial, poly means many. Poly means many, is a monomial or the sum of 2 or more monomials. So a binomial would be a polynomial, a trinomial would be a polynomial, but a monomial is just a monomial because it's just one. So an example here would be something as outrageous as, let's say, 3x squared minus 4x cubed plus 7x plus 18. And those are 4 terms. They're each separated by an addition or subtraction sign. Therefore, a polynomial. Degree. It's the highest exponent of the variable within an algebraic expression. So, for example, if we were to look at, say, 4x cubed plus 2x squared minus 5x plus 1, the degree here would be 3. That's the highest exponent. Now, another example would be, suppose we have 3x squared plus 4x to the 5th power plus 9. My degree here would be 5 because that's the highest exponent, right? So degree of a polynomial. So the greatest degree of any term in the polynomial will give us the degree of the polynomial. So when we talk about degree of a polynomial, we need a polynomial for that. So here's a complex one. Suppose we have 2x to the 5th minus 2x to the 6th times y to the 3rd times z to the 1st plus, so far this is 2 terms. I'm working on my 3rd term, plus x to the 5th, y squared, z to the 4th. Okay, so this is a trinomial, there are 3 terms. I know this because they're separated by a subtraction and addition sign. The degree of my first term is 5. The degree of my second term is 10. And finally, the degree of my third term is 11. Therefore, the degree of this polynomial is going to be 11. Now, how did I come up with these numbers? Well, folks, if you look at the exponents, of each term. So here we have x to the 5th power. There's no other variable. In my second term here, I have x to the 6th, y to the 3rd, z to the 1st. If I add up those exponents, I get the power of 10. So that's a degree to the 10th power. My third term, however, has degree to the 11th power because when you add up your exponents, 5 plus 2 plus 4, you get 7 plus 4, which is 11. Therefore, the degree of your polynomial is 11. So note the degree definition between degree and degree of a polynomial. Okay, standard form of a polynomial. Standard form of a polynomial is written with the terms in order from greatest to least, in descending order. So if I were to write A, that represents the leading coefficient, the constant on, or not the constant, but the coefficient on x cubed, plus bx squared, plus cx to the 1st, plus my capital C constant. That's just a constant, okay? This is written in descending order, as you can tell, 3, 2, and 1, okay? We can even have something where it's not going in order, but it is going in descending order. So we could have something like a times x to the 5th plus b times x cubed plus my constant c. This constant is just a number, no variable. This is written in standard form. So understand that you could be missing x to the 4th, you could be missing x to the 2nd, you could be missing the x even, and x squared. But you must make sure that your exponents are written in descending order. Okay, leading coefficient, you've heard me use this term before. It is the coefficient of the first term when a polynomial is in standard form. So suppose I have the standard form of the following. We've got 5x cubed plus 2x squared minus 1x plus 7. The leading coefficient here, LC, is going to be a positive 5. That is the leading coefficient. Notice how my exponents are in descending order, 3, 2, and 1. We don't write 1 there, but it's there. It's in descending order. That makes my leading coefficient a positive 5. All right, term. We talked about the definition of term. It's a number or a variable or a product of numbers and variables that are separated by addition or subtraction signs. So I want you to write separated by addition or subtraction signs. Okay? Constant term. Constant term is a term that has no variable. It's just a number. So that represents C in a polynomial. C, this is a constant, just a number. No variable. So that could be a number just like positive 3, or -2, or even a yuck number, +17. Finally, like terms. Terms with the same variables with corresponding variables having the same exponent. So you know like terms, combining like terms. So suppose you have 3x squared plus 5x squared minus 7x squared. These are all like terms. Yeah, sure, you've got different coefficients in front, but they are like terms because you have the same variable with the same exponent. So you can combine these like terms and you would end up with an x squared. Let's try it again for the next one. Suppose you have 4y plus 2y minus 8y. These are all like terms. When you combine these three like terms, you end up with a -2y. Same base, same exponent, power of 1. Okay, let's talk about degrees, names, and their shape. So if you have a degree of 0, this is a constant, say a number of 3. It's just a number, just a constant. This is how your graph would look like. It would be a horizontal line, y is equal to 3. A linear could be positive or it could be negative. And that's when y is equal to x or y is equal to -x. This is y is equal to a positive x. This is y is equal to a -x. So I'm not going to worry about the negative counterpart. So don't mind that. I'm just going to erase that. I don't want to be concerned with the negative counterpart just yet, okay? Quadratic. This is a quadratic. This is a parabola. Y is equal to x squared. A cubic looks like this. This is y is equal to x cubed. Quartic, yep, you guessed it. Y is equal to x to the 4th power. Here's what that looks like. It looks like a W, okay? This is the positive version of it, positive x to the 4th power. So if you can, imagine the x-axis cutting through there. Quartic means that your function cuts through the x-axis 4 times, okay? So we're not going to worry about that right yet. We'll worry about that in Algebra 2. Quintic. Yep, you guessed it. Y is equal to x to the 5th power. Now, if x to the 4th power cuts through the x-axis 4 times, imagine x to the 5th power. That would be 5 times. So that would look like 1, 2, 3, 4, 5. And then here you have the 6th degree, sextic. Yeah, but we're not going to write that out because, well, obvious reasons. I don't want you guys giggling over such silly, silly terms. And here we have 1, 2, 3, 4, 5, and 6. So you'd want to write your equation as y is equal to x to the 6th power. Now keep in mind your degree. This tells you, typically, tells us how many times the function crosses x-axis. Not always, but sometimes. So the exception would be cubic. But we'll revisit that in Algebra 2. For now, this is your vocabulary. Familiarize yourself with these terms, all of these terms. and these terms in this column. Like terms, constant term, term, leading coefficient, standard form of a polynomial, degree of a polynomial, degree, polynomial, trinomial, binomials, and finally, monomial. All right, you have one more video to watch. Talk to you then.